What really happens if you measure a qubit continuously instead of taking one clean snapshot? In the energy filament theory, continuous readout is a stream of tiny couplings that partially close and write partial records. So the state is guided along a noisy trajectory shaped by how hard and how often you listen. People imagine measurement as a neutral camera, but measurement is a physical operation. You couple an apparatus to the system. You force some degree of closure to happen, and you amplify it into memories that the world can keep. Continuous readout just means you're doing that in many small bites, not one big bite. It's like keeping your hand on a doorknob and feeling tiny vibrations instead of slamming the door once and hearing a loud click. You gain information gradually, and you disturb gradually, because each listening still perturbs the local tension landscape of the energy sea. In superconducting qubits, the readout often works by populating a resonator with photons. Those photons pick up a state-dependent shift, and the moment they leak out into an amplifier chain, they carry a record. More photons, stronger coupling, clearer signal. Also more backaction, faster phase diffusion, and a stronger push towards the pointer corridor your readout prefers. You can picture it like shining a brighter flashlight on a soap bubble. Yes, you see it better, but you also heat it and pop it sooner. Or like a security camera in a room, the more frames you record, the more the subject's behavior is constrained by being continuously accounted for. There's also a brutal engineering trade. If your readout isn't efficient, you still disturb the system, but you don't even get clean information back, which is the worst deal in the universe. And this is where quantum Zeno and anti-Zeno stop feeling like philosophy and start feeling like control theory. If your probing cadence is faster than the time the system needs to build a transition corridor, repeated rewrites interrupt construction, and dynamics freeze into a plateau. If your cadence and bandwidth accidentally match the noise spectrum, you can widen leakage routes and accelerate decay. In this language, measurement cadence is a metronome, and measurement strength is a hammer. You can either keep knocking the structure back into its starting groove, or you can rattle open a door you didn't mean to open. Even quantum non-demolition is not free. Maybe you avoid energy loss, but you can still scramble phase, because information still has to leave to become a readout. Next, we'll face a quieter question that hides in plain sight, even with no camera at all. Why do excited atoms emit light? Who is knocking on the door? Tap follow, share it on New Physics, Clear Universe.